I'm going to take you on how to form your table of value from your question. We are still on how to report our practical physics practical, and I told you that step 1, date your work. Step 2, the purpose. Step 2, the purpose. Step 3, the materials. Step 4, the method. Step 5, the results. And the results, I told you, the results include from the data, the table of value, and your graph analysis. Now that is what is taking us to today's service, today's class, table of value. Now we'll go back to our question. WAEC question 2006 practical WAEC question. If you are in Africa and you have gotten your WAEC question and answer, then you can follow up. Turn to 2066 WAEC practical. Question number 1. 2004, I mean, WAEC practical. Question number 1. Then we go. Read.
You have been provided with a meter stand.
A meter stand.
Clamp and balls.
Yes.
A meter roll.
Yes.
A spiral spring.
Yes.
A set of selected weights.
Yes.
And a pointer.
Yes.
1. Set up the apparatus as shown in the diagram.
Yes, that is the method.
2. Read and record length L0.
Read and record.
Length.
You are starting your table of value. Read and record what? Length L1. So because you have not added any mass, if you go through the question, you see you will not vary that L0. So you are going to just create a space. If you're drawing your table of value, you create a plain row, where you did not calibrate in case you have a constant throughout the experiment. So first constant we have there is L0. So write it here. Our L0 is equal to, you leave it. Then number 2.
3. Place a mass
then
is equal to 50.0 gram.
Place a mass M. You see it? Remember your first row is your serial number. Then the second row you start, place a mass. The variable have started. A mass M. What you call the mass there is M. If you call the mass T, if you call the mass B, you will write B. Any letter that is assigned to value is what you use in your table of value. So our first is mass M. Mass M. And it's 50 gram. In first rule is that the unit must be there. What unit? There must be a unit assigned to all the value. If you leave any value here on table of value without the unit, your table of value is 0. So you must take in consideration of the units and be careful about it. So 50 gram. So I write my mass. I write gram. You're not going to write gram all over the unit, all over the values in the table of value. Once you write it at the headings here, the value covers all the value here is now in gram. Okay? Yes, because they are the mass. You can continue.
On the hanger. Then 4. Read and record the new length L1 of the spring.
And record the new length L1. Is another quantity we are measuring there. L1, the unit of L1 is in length is in cm. The unit of length is in cm. So you note the units. Remember the first rule, you must what? Write the unit. Indicate clearly the unit of any quantity you're recording in your table of value. Then number 3, continue.
Number 5. Determine the extension E is equal to L minus L0.
Okay, he said determine the what? Extension E, and what he called the extension there is what? E. Determine the extension E. So you write your E, and he told us that the E is equal to L1 minus what? L0. So that is our E, all in cm. Remember your table, your units. Continue.
Then set the system into small vertical oscillation.
Okay.
Measure and record the time T for 10 complete oscillations.
Okay, we pause here. Once you see any oscillation in your practical, you make sure you repeat the oscillation, the process. You do it in two ways. One, for accuracy. That is why you do it in two ways. So in this table of value, we are going to have our time for 20 oscillation. Another constant 20 oscillation. 20 oscillation is another constant that we are going to have all through the practical. And the time is what? T. We are going to have T1 in seconds, T2 in seconds. That is the unit of time is in seconds. You are going to repeat the practical twice so that you can get for accuracy. So when you have your T1 here, you repeat the oscillation 1, you do the oscillation 2. For 20 oscillation, each length, each mass you add, you do the experiment to the oscillation, the simple harmonic motion, you do it oscillation into 2. Okay, you get your T1, you do it T2, and you now get your average T. And is that your average T you are going to make use? Reason I say this for accuracy. So your average T is now equal to T1 plus T2 all over 2, all in seconds. Okay? Always remember your unit. If not, your table of value will be 0 and your graph 0. You can continue.
Determine the period. Then,
determine the period, capital T. Write it. Once you see, determine any value, evaluate, determine, read and record, you come and write it on your table of values heading, because you'll be varying it, and that's how to form your table of value heading. And as you're performing your practical, you just be fixing in your values. Continue.
Of the oscillation and evaluate T2.
Evaluate T2. That is T raised to power 2, T squared. Once you have square in a value, which means the value, the unit will be in square. You understand? Yes, all right, so continue.
Then, repeat the procedures for 4 other values of n equals to 100.0, 150.0, 200.0, and 250.0 gram. Tabulate your reading.
Our table of value heading is completed. Then we'll go for the practical proper. Now here, I'm just teaching you how to form the table of value. We are not in a practical setting. So because of that, in some cases, I'm going to assign value to them as we move forward. Now, what is the value given to us there? What are their own value they gave to us before they tell us to vary the values? They gave us masses. It's the masses they gave to us, right? So we are going to fill in the masses. But in this mass, in this case now, we'll come to another rule that of your decimal. You take note of your what? Decimal places. Okay? Now, in this case, I advise students to choose 4 decimal places. Reason is in your exam, if your decimal places is above the required decimal places, nobody will penalize you. But if the decimal places is below the required decimal places, you'll be penalized. Now, instead of you to go into exam hall and you are asking yourself, which decimal places am I going to choose? Which one is suited to this one? You better choose 4 decimal places, because 4 decimal places is the highest decimal places you can choose. because of the 4-figure table. Okay, so you will make use of 4 decimal places, and all true. If you make use of 4 decimal, you can't just write because it's 10. You not write 10 here. No, you're going to use proper decimal places. It's very, very necessary. If your decimal places is below required, your table of value is 0 and your graph is 0. This is why when some people, students go to exam, they will say they really know what they wrote, but the examiners fail them. No, it's because you just fail an important rule. Okay, so to avoid you having issue with decimal places, you choose 4 decimal places and you make your table of value uniform. Now let's go. The first question is say that the mass given to us is what? 50 grams. So write 50.0000. If there is no value to form the table after the point, you just put your 0. You can complete your table of value if it's 2 decimal places. You want to make it 3 decimal places with zeros. Okay? So we have 50.000. That is serial number 1. For serial number 2, we have 100.0000. For serial number 3, we have 150.0000. For serial number 4, we have 200.0000. Serial number 5, we have 250.0000. Okay, we are through with our decimal fixing in the values that they give to us. Now you do your practical. As you do your practical, you have your mass hanger, you calculate the value. Assuming if you hang that mass hanger and we get the length to be 29, okay, 29 cm. I'm teaching you how to plot form the table of value. Then you now measure the extension. Okay, you measure the extension. Now we go in fixing the table of value proper. Okay, you follow me. As I use my own answers that gotten from the experiment I performed with this thing. So we are going to use my own answer I got from the lab to fixing this table of value. Okay, but in next class, when we are through with the steps, then we will now start with the practical proper. And as we are doing it, you will just follow the processes I'm going to teach you now. Okay?
Yes, ma'am.
Gram mass. My new length was 37.5. When I added 100 grams, I got 37.8. When I added 150, I got 42.1 as the new length. Then when I added 200, I got 46.5. Then when I added 150, the length was 50.4. Now these are the answers I got. Now I have to fix it up in my table of value. Now remember I said it must be what? 4 decimal places. So I write for serial number 1, that is 37.3000. I use 0 to complete it 4 decimal places. Now not serial number 2, 37.800. Serial number 3, 42.0000. Serial number 4, 46.5000. Serial number 5, 50.400. Okay, I'm done with L1. Now I go for extension E. The question says that the extension E is equal to L1 minus what? L0. Okay, so my extension E, where I see L1 in serial number 1, I fix it the value I got when I added 50 gram. Then when I see L0, I fix in 29 because that is the value I got when I fix my mass hanger before fixing in 50 gram. So whenever I see L0, E is equal to L1 minus L0. Okay? So where for serial number 1, the mass hanger is 50 and the length, new length, which is L1, is 337.3 minus my L0 with the length of the spiral spring before hanging with only mass hanger is 29 cm. Then for serial number 2, 37.8 minus 29. For serial number 3 is 42.0 minus 29. For serial number 4 is 46.5 minus 29. Then for serial number 5 is 50.4 minus 29. The answer here is what I'm going to use to fix it under extension. Now 37 minus 3 minus 29 is what? What is, you use your calculator to calculate this to avoid error. Now 37.3 minus 29 is what?
4.2.
4.3. Now 37.8 minus 29 is what?
Is 8.8.
8.8. 34.0 minus 29 is what?
13.0.
13.0. 46 minus 29 is what?
17.5.
17.5. 50 minus 50.4 minus 29 is what?
Is 21.4.
21.4. Is this the answer here? I want to fix it into my what? Table of value. Now for serial number 1, my extension is what? 4.4. Remember it must be uniform. 4.3. That is 4.3. I use 0 to complete it. 4 decimal places. Then 8.8000. Then 13.0000. Then 17.5000. Then 21.4000. Okay. Then from my experiment I perform, I have my time T1 and my T2 gram, and the oscillation T1 is 5.45 and T2 is 5.81. And when I added 100 and displayed it, I had 7.6, 7.1 for serial number. For 150 mass, 8.0, 8.5. For 200 mass, 2.2, 9.21. For 250 mass, I have 10.0 and 10.01. Now I fix it into my table of value. How do I do it? Remember 4 decimal places. I have under T1, you fix all the value you got in T1 the first performance, and all the value, the repeated oscillation, you fix it under T2. That is the time for the performance. Now for serial number 1, we have 5.7500. For serial number 2, we have 7.600. For serial number 3, we have 8.0000. For serial number 4, we have 9.2000. For serial number 5, we have 10.0000. Now for T2, we go for serial number 1, 5.8100. 0. Then for serial number 2, we have 7.010. Having gotten our average T, and period T is average T divided by number of oscillation. That's our period T. Now calculate in each, period T, n over what? T over n. So where you see T, you fix in your T, and where you see n, you fix on 20, which is the number of oscillation. Now let's go. 5.78 divided by 20 is equal to
0.5780.
0.5780. Then for 7.305 divided by 20 is equal to
0.7305.
0.7305 approximately. 8.015 divided by 20 is what?
0.8015.
0.8015 approximately. Then for serial number 4, 9.2 divided by 20 is what? 0.9205 approximately. 10.005 divided by 20 is what? 1.005 what? Approximately. Okay. Now we fix in into our table of value. For serial number 1, 0.5780. For serial number 2, 0.7305. For serial number 3,
0.8015.
For serial number 4,
0.9205.
approximately. For serial number 4,
1.005.
1.005. Okay. Then we'll go for our T square. The T square is this period square. This period square. If you don't understand what I mean by T square, is 0.5780 times 0.5780. Now 2 square, permit me to write here because of space. 2 square is equal to 2 times 2. Okay? Yeah. So it's just repeating using the value to type times multiply itself. That is the square of that value. Okay? Yeah. So we can now go for T square is what? For serial number 1, what is T square?
Is
0.0317. Then for serial number 2, 0.5336. Serial number 3, 0.6424. For serial number 4, 0.8473. For serial number 5, 1.0010. All right, as you can see, the table of value is completed. The table of value is what? Completed. Do you like the way the table of value is neat? Yes, ma'am. Then your table of value, the values must be uniform. That is another rule. Number 3, your table of value must be uniform. Of value must be uniform. Okay? Having known how to form table of value, we are going to try other table of value, other questions using this method you are going to try, but because you are not performing the practical, I will only give you assignment to form these headings. Okay, try other headings. In 2004 WAEC question, practical WAEC question, form the headings using question number 2 and question number 3. Then form the headings using 2006, 2005 WAEC practical question. Try if you can form these headings. Remember, the unit must be there. Remember, and fixing the value that is the variable that is given. Okay, fixing the variable using the proper decimal places. So when we are doing the correction, then I will show you, I will fix in the values for you, because I will perform the practical before next class. Okay, now I want to tell you, if you have any question, you can use our WhatsApp number. You can get us on our WhatsApp number, our WhatsApp link. We are waiting for you. Okay? With this, you can find out that to form table of value is not difficult. And in a physics practical, it is necessary reason if your table of value is correct. If the answer, the total mark is 30%, you've already gotten your 50%. It's always the half of the practical work. Okay? The half mark of the practical work. So love you. Next class we continue with graph plotting. Okay? In next class we continue with graph plotting.